When we solve an equation involving radicals, the first thing we want to do is to isolate a radical and then raise both sides to the appropriate power. Well, in this problem, we already have a radical isolated, so what I'm going to do is square both sides. So we have radical 7 minus x, that's all under the radical, squared equals x minus 5 squared. Squaring this side, the square and the radical undo each other, so I get 7 minus x equals, on this side we have to be careful, we actually have to multiply x minus 5 times x minus 5. If we do that, we get x squared minus 10x plus 25. We now see we have a quadratic equation, and I can subtract 7 and add x to both sides. If I add x, I get minus 9x. If I subtract 7, I get plus 18. Well, this can be factored. X minus 6 times x minus 3 equals 0. So it would appear that x is equal to 6, or x is equal to 3. However, since we squared both sides of this equation, we must go back and check our solutions. So let's come back up here and check. If x equals 6, then we end up with the square root of 7 minus 6, and we would like to know whether that's the same as 6 minus 5. Well, 7 minus 6 is 1, the square root of 1 is 1, and 6 minus 5 is 1, so that solution checks. X equals 6 is a legitimate solution. If we look at x equals 3, we have the square root of 7 minus 3, and I want to know whether that's the same as 3 minus 5. 7 minus 3 is 4, the square root of 4 is 2, and 3 minus 5 is negative 2, and I see those two numbers are not the same. We would say in this case that x equals 3 is an extraneous solution. So the only solution is x equals 6. We only have one solution. It appeared that we had two, but one of them was extraneous.